I go to Canada a lot in the summer, and driving past all these wind turbines, you watch them turn, and it sparks different questions. Why do they always seem to turn at the same speed? Why are they sometimes not turning? So it's like, hey, let's use this as an opportunity to apply the concepts of rotational motion to a project where we're also exploring green energy. There's a controversial issue in many areas. Do they work? Are they effective? It just seemed like a multi-dimensional application to have kids really get to know how they work, and it really overflowed for me.
We were given a couple weeks to create a turbine, and the goal was to create the most voltage and RPMs to create wind power from it and energy.
They needed to convert the power of wind into electric power. This one would measure the voltage, and this one measures the current in milliamps. We run them through a 2-fan system. We would video these, and the students can pick their highest combination.
My group reached out to 3 companies, and we emailed them asking them questions about the model of our turbine, which motor would be best, and before that we researched what we thought would be best, and then to clarify we asked professionals. We
went to old videos. I have a video from I think World War II, where they showed a video to probably 18-year-old boys that were going to be underwater in submarines and had to know how a motor worked in case one broke.
Relative motion, the basic requirement of an induction motor, has been satisfied. The rotor turns.
It became this really deep and dimensional project.
It's the simple ideas of today for students or some of our future engineers. It is important for them to start learning these ideas, starting to make these creative ideas on how to design these devices, because the world does have an energy crisis, a developing energy crisis.